Hey, what's up, dudes? What's up, bros? Alright, so here we go. It's a new day, starting our timer, 68 minutes. Today's the 22nd. We did code yesterday a little bit. It's 5:07 start time. And what did we do last session? Well, we did save logic revision code test SQLite. High general huge readability logic improvements. We refactored SQLite test code sections that we've been working on, tested after changes, verified working. Essentially perfected this code. I don't think it can really be improved any further. We're at like 99%, you know, personal 99%. Obviously, some genius could come along and just completely change it for the better. But as far as my capacities go, that's about as good as I can get it, honestly, without just wasting time. I feel like it's at that point where it's good, it's very good, you know. It's like it's very good, and then you reach that point of where it's like 90-10 or whatever you want to call it, where it's gonna take like 90% of the time that it took me to that I've already worked on it to make another 10% improvements, and it's like if the graphics are almost real, do we really need to spend another $1 billion? You know, to increase the fidelity of the raindrops by like 2%. So, you know what I'm saying? It's perfect enough for me. We stopped at line 441 in SQLite test. So let's go over there to 441 in SQLite test. Let's see what we got. First, we have to reset our extensions. We do have Python that needs to be restarted. That's the most important extension as far as I understand it anyway. Okay, so this is where we stopped. Our next task is to, since we always call this function 2 times, why don't we just add the second part of the call inside of the function itself? Since we always call this function 2 times, okay. So then we just call the function 1x and it creates both stable and backup internally. I mean, like, honestly, it makes more sense to do it that way. Do I really want to do it? I really don't. I really would just rather call it twice. It's not that big of a deal. You know what I mean? Like, do I really need to do this? Not really. And I may change the name of this function from vacuum into integrity check recreate to just like create save backup. You know? Create save backups. Because that's really what's happening is that function is creating the save backups. I mean, that's literally what it does, you know? Well, okay, so here's a gain. I don't like args in functions. I think they're a nightmare to deal with sometimes. If you've ever had a function that had a lot of arguments, you probably know what I'm talking about, and like just ordering them correctly, and you know, it can be a nightmare. So in my opinion, the less args, aka parameters, you have in a function, the better. The safer they are. So I would say if we can remove this parameter altogether, we could do that, I think. Yeah, because this is a method of the database class, and that means we have access to these target paths already. So since the order, like, since we always do these two back-to-back, stable backup, stable backup, stable backup, then that means we don't even need to have the target path. We can just not only combine this into one function call, but we can also remove the target path parameter. So in that sense, it does make me feel like it's worth it to make that change. But first of all, I think what I'm going to do is rename this function. We're going to rename it create DB backups. Or should we call it create, what should we name this? Because what does it really do? It creates the, well, it creates the new database backups. Well, it's not necessarily a backup. It creates the new database save points. Create new database save point, or just create new save point. But specifically it is working on the database, so maybe we should say create database save point. We don't even have to say new. New is kind of implied, right? So or we could just say update database save point, or update database save state. I think that's even better. Update database save state, because that's exactly what it's doing. It's updating the database's save state. But specifically, it's stable, right? This is all about stable. So update stable database save state. That's a better name, because this was around the fact they were using vacuum, but that's like not, I don't like that. So let's go ahead and change this. We're going to do Control-Shift-F, and we'll find all the, actually we'll just do it like this. Let's go right here, copy F, go over here, and we're going to change this to be update stable save state, update stable save state. Update database stable save state. I like that. Update database stable save state. Yeah, we'll go with that. That's better than the one we have, so we'll go with it. All right. Let me make sure I don't have like an empty space at the beginning or the end. Whoops. Hit the wrong button there. All right. Well, I just realized that kind of does conflict with the stable save state function. So this function, stable save state function, I mean, that's a good name, stable save state. And then what this one specifically does, I guess, yeah, that's still a good name. We can have them both. Stable save state function is the broader overall function, and then update DB stable save state is specifically what it does. So yeah, we're good with that. We'll go with it. Okay. Oh yeah, aren't we getting rid of the DB stable and DB backup? And the cursor stable, cursor stable backup. Yeah, we're getting rid of those. They are throwaway. Yeah, I think so. I think so. And then same thing with cursor stable and cursor stable backup. Yeah. Totally forgot what I was doing. Like I just had a brain fart. What was I doing here? Oh yeah. Duh. Just replacing this name. So they're not actually going to be assigned. SQLite connection. Placeholder. SQLite DB connection. That's not really where they're assigned. It's assigned in. It's assigned in that other function. Setup. Something setup. It's not going to show because it's considered a comment. Where is it? Not visual data, save function. Save DB setup. Yeah, so that's the one. Assigned in, yeah, and that is where it's assigned, right? Yep, that's it. Okay, so yeah, that needed to be changed. And these, yeah, like I already know this is SQLite cursor object purpose placeholder per SQLite cursor, and then we can just copy this directly because that's literally what it does. Or that's the truth right there. Change that to the new name. Alright, and these need to be changed to okay, so I think we changed everything except in devlog, but we're going to leave devlog alone. Alright, so let's go back over here to SQLite test. And now what we're going to do is, I forgot to share the stream. There we go. Okay, so what are we going to do now? Well, now we need to make this into one function call. So let's go up here, and we're gonna we're going to remove the target path arg altogether. So it's just going to take self and okay, I see what we have to do here. So we have to modify this. It's not as simple as okay. So if OS path exists, well, hold up. Maybe we can't do this because they'll like we don't. Well, it's quite simple, really. We're gonna vacuum into whatever target path. We're gonna do stable first. We're gonna do backup second. So I guess we could just do I want to see if I can fix this a little more. If we do if stable and then if backup. So we have stable, then we have backup. Okay? Then we run this shit. But do we need to run that? Can't we just let that happen in here? Like, why do we... So we're checking to see, like, I'm wondering, do we actually need to do it this way? So we check for stable, we check for backup. We have, if we have both, we create a connection to backup, we create a cursor, we check to see if it's okay. We close that connection. If it is okay, then we create stable, and then we re-update backup. And then what about else? What about if it's not stable? Well, we actually don't have a scenario for that. I just realized. If it's not okay, what does it do then? What would we do differently? If the database, if the backup was not safe, so we have a stable backup, and then we have an actual backup as well. But let's say stable, let's say the backup is not like healthy. Well, how do we know that the stable is healthy? You know what I mean? We don't actually know if any of these are healthy at all. If they're good to go. We assume that they are. But wait a second. Well, they could... Shouldn't they already be verified to be stable because we don't let them get created unless they're stable? Yeah, that's true. And we don't even mess with them. Like, we don't even... Thinking about whenever we load in, like whenever we reconnect, okay? So let's say we disconnect, then we reconnect. We have to load from one of these databases. Like, could it get corrupted in that case where we go to, like, load it in? See what I'm saying? Because if we could corrupt it on an attempt to load it in, Well, that's why we have the backup, right? We start with stable. If that one like gets corrupted or if it doesn't work or whatever when we try to load it in, we would fall back to the backup. Well, and then if that one got corrupted upon loading in, well, we're just fucked. There's nothing really we could do about that. And I think the point of SQLite 3 is to like basically guarantee that doesn't happen. So like there's really no point in running an integrity check at that point. I mean, I guess it's a good practice to just verify that it's fine prior to loading it. So ultimately, like, that doesn't influence what we do here, I don't think. I don't think it has any bearing, because that's what I was trying to figure out. I was like, well, maybe that will affect the way that we should execute this logic, but I don't think it does. So here's what we'll do. I'm not going to worry about that logic. I don't think it ties into this at all. Let's look at this. Let's continue down that path. If data stable exists and then backup exists, well, the last time when it was created, we verified that it was safe. So if the only time that a database is touched is when it's created and when we load it in, and if when we load it in, it doesn't matter, like, I don't think we can corrupt it when we load it in. You see what I'm saying? Like, my concern is that we could load it in, corrupt it somehow in that process, but still load from it, continue to play the game, update that database in this function, and then when we go to update it, and then, well, whenever we go to update it here in this function, what else? I don't see that that ties in. Okay, right. Now I'm remembering. Okay, so I'm like, why would I need to check the integrity? Well, in the case that I loaded in, corrupted it, but somehow was still successful in loading it in, which I don't think can actually even happen. That just doesn't make sense to me. But you know, maybe there's like an infinitesimal chance. In that case, whenever we ran this function, that would it would be wise then to do an integrity check on it beforehand. But like, does it matter? Like, is anything gonna change if we do this or don't do it? And I just don't think it will change, like, because remember, we changed the order. We don't do backup and then stable anymore, because we had it set up to do we have it set up to do because we don't check if stables has integrity. So I'm gonna go ahead and just say I'm like 99% sure you can't corrupt a database by loading it in. You're just reading from it. Especially if it's a successful load in, it kind of doesn't even matter if it's corrupted. If it is corrupted, well, who cares? You load it in from it. You don't really need it anymore. Like, what does that knowledge give you? It's like knowing the price of rice in China. Like, who gives a fuck? What does it matter? It It doesn't change anything. So I think this might just be dead code, honestly. I don't really remember why. I don't like deleting code that I put my double stamp of approval on and stuff, but I just don't really see a good reason to have this. I don't see. And honestly, God, I hate to say this, but if we end up doing these same two function calls anyway, couldn't we just delete all this logic and just call this function twice? Well, and then we're gonna change that to be one function call. Yeah, like I feel like, why do we need, if ultimately we're gonna do the same thing every time, regardless of the conditions, that means there's really no point in in checking the condition, right? It's the same like concept of the price rise in China. If it doesn't influence what I execute, then why does it matter? Well, it doesn't. That's the thing. It doesn't matter. So I think, honestly, if OS path exists, and the reason we added this initially was because we needed to make sure it got deleted. Reviewed all the logic in the area. Keep it as is. Safety nets for possible corruption during database copies. So the goal here was, if stable was created, but like got corrupted, we would fall back to backup. But I mean, that makes sense. On a reconnect, you just check, you do an integrity check on stable first, and if it's stable and the most recent, well, then you do you would load from stable, and then if stable was corrupted, then you would have to load from backup. Does that make sense? So, like, it's okay to have safety nets, but I think this is like a wasted. This net is basically never gonna catch anything. It couldn't. It's just useless. So, honestly, I think we could just do serialized checkpoint ID, insert or replace into saved data, add that checkpoint ID to save data, and then we could just straight up call this function right here, back to back, right? And well, it would just be one call because we're going to change that, and then it will check to see if the path exists internally. So instead of checking it here, it's going to internally check to see if stable exists. And then if stable exists, okay, I remember the logic now of this safety net. It was, if we find that we have stable, but we don't have a backup, we want to create the backup first, because if we don't have a backup, that means if during the deletion of stable, that means we don't have anything to fall back on. So instead of doing stable first, we do backup first in that scenario. So actually that is a valid safety net. Okay, see, I remember now. Yeah, it's a pretty rare scenario and it probably would never happen, but theoretically it could, and I do like to account for rare instances like that. So let's see. I think what we'll do, that would mean, honestly, this should be backup and then stable. Yeah. And I'm just trying to like get this optimized here. Like maybe we can do this, and I'm gonna put backup first is necessary here, safety net, to have a valid backup before deleting stable. Because in this case there is no backup. Yeah, we want to have one before we actually delete stable. It's just a safety net. And I think we would add in as well the stable save point. So let's say add in time checkpoint created to save data along with checkpoint ID to determine which DB to load from, aka which is most recent, since it varies whether backup or stable is the is that true. Okay, so there is a reason that we check this, and it does influence the order of this function call. So if we were to, what could we do? My question then is, we're checking if OS path exists, and then we're checking it again in the in this function. Doesn't that mean, like, we don't need to check that, right? Let's see. In this case, I thought, let's see, this line is okay. So I already went through this. This line is necessary, varies whether path exists when function is called. Got it. Okay. True. Okay. So yeah, I don't think I can really make many improvements here. I thought I could, and then I'm glad I didn't make that quick decision. But I do wonder about this. The DB backup, and then we check to see if it's valid. Like, why don't we check to see if stable is valid? Well, let's just go through this logic here. If we have stable, and for whatever reason it's not integritous, it's not safe, then what? So if we have stable, we check to see if it's good. Well, let's just say it's not good. Well, then we would check to see if backup exists, and if backup is good, well, then that means in that case we should delete stable and recreate stable, right? Yeah. We should recreate stable. Because if stable is not good, but backup exists and is good, then we don't want to, we want to make sure we do stable first. Now, what about if it was good? If stable was good, then does it change anything? Like, does it change the, the result, the final execution? If stable was good, well, then it would just depend on whether or not backup was good on which one we would do first. If stable was good, but backup was not good, we would do backup first. Hold up. See, this is confusing, bro. This is a little zeros and ones game. It's really honestly confusing. I didn't want to spend this much time on this shit. I wanted to be done with it. But I gotta get it right. So let's work through this. It's like fucking calculus. It seems simple, but it's really not as simple. This actually checks if it is okay. If it is okay, if we have a stable backup and we have a stable basic initial backup, why would we do backup first? I think I changed the wrong one. It was supposed to be if we have stable and backup, you do stable first, then backup. If you have stable but no backup, then you do backup first. Right. So this is the one. I just mixed it up here. So this needs to be so I just put this in the wrong place. Got to be careful there. So let's read that. What the fuck? Where are we at here? Okay. Backup first necessary here. Safety net. Yep. Okay, and then if we have stable... If we don't have any stable, that means it's our first time copying from save to... Well, this could be a case wherein we... Well, no, that would mean the path wouldn't exist at all. So if the path exists... If stable exists... versus if it doesn't. If it doesn't, well, we honestly should check to see if backup exists. But why would that ever be the case? That would never be the case. Well, technically it would in this rare scenario. No, that's not true. Yeah, so that would never happen. This would only mean that it was our first time copying from save data to save data stable. Yep, so we do stable and then stable backup. That makes sense. Yeah, because when you're using a program at scale, you have to program this way. You know, if I was just throwing something at the wall, like personally, I'm pretty sure this would never happen. But I want to code in a way that is meant for, like, you know, if it's being used by a million users, those little rare instances will actually pop up a lot more than you think. So it's good to have these safety nets. So we're going to leave this logic. We're going to leave this logic as it is. So we do db backup, db cursor. Is it okay? Close, back cursor, none. If it's okay, then we do stable and then stable backup. But what about else? If stable is not okay, then what? I mean, if backup is okay. Say db backup is okay or not. And then if db backup is okay, and this can just be changed to is okay. So if is db backup is okay is equal to okay, then we would do stable then backup, but then else, which is elif db backup is okay is not equal to okay. Well, in that case, then what? What do we do? What do we do here? In this case, we would do the same thing. Well, no. In that case, we would want to do backup first to retain stable. Because if we did stable first, we would be deleting our only backup. As to where, like, because the backup is corrupted. So if the backup is corrupted, well, we can't load from it in the case that we crash during the creation of the stable. So what we should do is, since we have well, we're assuming that stable is safe. In this case, we would want to do backup first, then stable. Now this is assuming that this is going to say, we're going to put the same thing here. So we have backup first. I kind of feel like an idiot. I feel like this is never going to be used. It's probably not ever going to be used. These scenarios are never going to happen. But is it professional? I don't know. I mean, technically it's the safety net way. Do I like doing it like this? No, I really don't like being this extra. But that's how you avoid bugs, bro. You can say you're a fast coder and just throw some shit up, but I would rather do it right, you know what I mean? That's just how I am. I like to do things correctly. Like all the way correct. For the most part. To the best of my ability. So if it's not okay, then we need to do backup, then stable. But this assumes that we're checking and have ensured that stable is good. And I guess it's good practice to do the integrity check prior, because that just makes sure that it just makes sure that it makes sure that we're not loading in or dealing with a corrupted database. It's just a safety net. 99 out of 100 is gonna be that case, but there is a rare chance that it could be corrupted for whatever reason. So if OS path exists, self save data stable path db backup. In this case, we're checking to see if the just stable is good to go. So we're just gonna say db cursor, or we'll call it db stable cursor. This is gonna be db stable. Stable cursor, and then db stable. This is like a tongue twister type shit. It's not really quote unquote complicated. It's like a puzzle, you know? It's zeros and ones. Okay, so now we're doing db stable is okay. And we don't actually use it, so we need to say if we have stable and it's verified to have integrity, then that means what? Well, that means, let's see, if db stable is okay, and we can put this in a function since we're repeating ourselves at this point. So if db stable is okay, we want to check to see if backup path exists, first of all. And then if backup path does exist, well, then we're going to check to see if it is integritous. Now, if both of them are okay, then we know we can do stable first, backup second. But if backup is not okay, but stable is okay, then we would do backup first and then stable. That's good. That's correct. Alright, that's nice. And then if it doesn't, if we have stable and it is okay, then backup doesn't exist yet. That means we would create backup first and then do stable. So this is all correct so far. Now what about else for if stable is not okay? So this is elif db stable is okay is not equal to okay. In that case, what do we do differently? Well, in this case, we would, I don't know. What would we do? Well, then we need to check to see if backup exists. If backup exists, then we need to see if it is okay. And then if it is okay, then we should do stable, then backup, right? Because if stable is not okay, but backup is, then we need to do stable first, because we could fall back to backup in the case of a crash during the recreation of stable. Yeah, we could fall back to backup in the case of corruption. So yeah, if stable exists but is corrupted, then we would do, and then if backup existed and it was okay, we would recreate stable first, then backup. In the case that it wasn't okay, the backup that is, that means both stable and backup are not okay. So in that case, we would do it differently. In that case, we would just do stable and then backup. It really doesn't matter, honestly, at that point, because since we're using the timestamp variable as our checker beforehand, in that case, since they're both corrupted, it doesn't actually matter. So ultimately, this doesn't influence anything, I don't think. If DB stable is corrupted, we would still do the same thing. If it's let's just triple check this. If stable is okay and not corrupted, and if we have the backup and it's okay, we would do stable then backup. But if backup was corrupted, we would do backup then stable. That's correct. If we didn't have backup yet, but we had stable and it was okay, we would do backup and then stable. So that's for sure. Now, if DB stable was corrupted and we had backup and it was good, we would do the same thing. Because stable is corrupted but backup is good, we would do stable and backup, and then else if it was corrupted, we could do backup and stable, but it doesn't matter the order since they're both corrupted. And then in that case, if stable was corrupted but we didn't even have backup at all, we would do backup and stable again, which really doesn't change anything. So this logic is good. I was gonna see if I could improve this since we have backup, stable, backup, stable. Couldn't we just change this to be like so it's verified. There's no point in checking it. There's really no point in checking it. So we're gonna just undo it. So we get rid of this. There's no point in checking. If there's no point in checking it, then why would we do it? Does that make sense? It does to me. Alright. Now what's the last thing? So there was a little bit more I wanted to check here. If DB backup is okay, is equal to... Since we have backup and then stable, I was trying to see... So if backup exists and backup is not okay, we do backup stable. And then, so we could just modify this statement to say if OS path exists, backup, and backup is okay, or is not okay, do backup then stable. But in the case that we could say if OS path exists and DB backup is not okay, or if OS path, if it does, the path doesn't exist at all. So couldn't we just say if OS path exists and it's stable, do stable then backup, and then we would say else else do backup and path, because in the case that the path doesn't exist, we would do backup and path, and in the case that backup was corrupted, we would do backup then stable. But that would require us checking backup is okay before we knew that the path existed. And if we tried to connect to a path that didn't exist, that wouldn't actually work. It would throw an error. So we couldn't check the integrity of the connection of the database without verifying that the path existed. because it does vary, right? It doesn't always exist. So we actually couldn't check preliminary beforehand whether it was okay, which means we have to do it this way. And it is a variable. It's not like I can just remove this backup, this else clause, because if it is okay, it's gonna do it this way. But if it's not gonna automatically enter into this else, which means nothing would happen. So that's actually, like, it's gotta stay this way. And what else? Wasn't there another scenario? So we did verify that there's no reason to check. We verified that there's no reason to check whether or not it's corrupted. So I'll just put that in a note here. And I know this is, I'm gonna come back and look at this and be like, why is it this way? And I need to put a note that says, don't fuck with this function anymore. We already looked at it like really hard, and we went through all the different possibilities, and it's kind of like a minuscule detail type scenarios, but it's correct. To the best of my knowledge, I feel like this is as good as it's gonna get. So we can't actually remove this double function call because of the fact that it does vary the order, that is, of like whether we run it on stable or backup. It varies. Sometimes we want to do backup first, sometimes we want to do stable first. Technically we could add just like we could add in, instead of adding in the path, we could add in like which one goes first. And if we do stable first, we would just pass in S, and that would cause us to do the process twice inside of the function instead of calling the function 2 times. But honestly, I kind of like this format. It's basically the same thing. We're still gonna have some sort of like I'll be right back. I gotta use the bathroom. It's complicated. Alright, I'm back. Man, I feel like this was so extra. But I mean, this code was thoroughly reviewed. I can definitely say that. Now, if there's something wrong with it, I'm going to be very upset. But I'm pretty sure we're good. I still wonder if we could do, instead of having the double function call, we would basically just say for path in, you know, like we would convert. I mean, that kind of makes it muddied as far as being able to readability. It's not terribly complex, but we would pass in basically S or B as a string, and it would determine which one gets run first, and then we would say for a path in this list of paths, if whatever string was equal to S, like that would determine the order of our list. So if S was passed, the order of our list would be stable path and then backup path, and we would iterate in that order. Otherwise, if it was B, then we would iterate with backup first and then stable second. Does that make sense? So that it would just be a reversed list order. But honestly, that adds more lines and is like, we're talking about 1, 2, 3, 4 lines versus, let's just say we would do list equals, well, we would have to say if x equals s, then list equals sb, and then we would say else list equals bs. So there you go. You already got 4 more lines added, and then you're gonna have to add in a 5th line to say for y in list blah blah blah, and that's just more complicated, right? It's just easier and simpler and less lines to do it this way. So we're gonna leave it with the double function call, and yeah, that's good. Verified correct. And I'm just going to put a little note here which says below 2 lines, double function call is most efficient, cleanest option. Verified. And, you know, I do like having these lines. I really, you know, just so that I don't change it in the future. I want to make sure I don't come back and change it again. I want to leave it as it is, and this comment hopefully will make sure that I don't fuck with it in the future. So what I'll do, basically we're done with this. I don't think there's anything else we can do really. The only thing that we, let's see. Oh yeah, right, we need to write that. Determined that we don't need to run, or that we determined that there is no reason to check stable integrity since it is verified to not affect final order of events, i.e. they would remain the same. Yeah, so there's no difference. We determined there's no reason to check stable integrity since it is verified to not affect a final order of events, i.e. they would remain the same. True. Got it. but it is important to check the integrity of backup, because that means that does determine whether or not we would do stable first or backup first. Yep. Alright, so I'm going to put here, below function I'm created, function which creates new stable save state in database, transfer from saved data DB to save data stable DB, and save data stable backup dot DB. Params checkpoint ID type. I hate that I just basically went through this again and didn't really change. Well, no, I'm sorry. I did fix it because it was missing this. It was missing this, and that did need to be added, right? That technically was a flaw in the function. So, yeah, cool. So in that sense, we did something that we needed to do. Was it worth it? Man, I hate it, honestly, when I code for an hour and I add fucking 2-3 lines of code. It really is demoralizing. I hate it. But it is what it is, you know. That's just how it is sometimes. So we do need to add in the time checkpoint created to save data along with checkpoint ID to determine which database to load from, aka which is most recent, since it varies whether backup stable is that. That being the most recent. And that would be added here. So we'll say current time equals time.time ns, and then we're gonna do serialized current time equals pickle.dumps current, can't type, current time. Okay, so current time equals time.time ns. We need to import time. Let's see, import time. Go back down here. Okay. So current time equals time.time ns. Serialized current time equals pickle.dumps current time. And then we'll do this. Self cursor execute and replacing save the object name, and this is going to be current time. We'll call this time checkpoint or time last saved. And it'll be serialized current time. And then we would do it again. Created for 22. Upserts the time last saved to reference last stable save state time stamp for proper reconnects. Yeah, because sometimes we saved to stable last I mean, yeah, because technically it could crash, right? Like, let's just say it could crash on the after the first one. This is you know, rare scenarios, but it could happen. It could crash on the first, and you know, if it crashed on the first, then it would ultimately, you know, we would need to know, is this the old one or is this the new one? Because if it crashed on stable after it did stable, well then um, we would want to load from stable because that's the most recent. But if it crashed in this case during where backup was first, well then we would want to load from backup because stable is actually old. It's the old form of it. We saved to, we updated. Well, actually, it'd be first. So then we could get rid of this. Now we would do. We verified. We wouldn't do that. All right. Now we're gonna do stable save function checkpoint ID. So it's copy current time, serialize current time, and then cursor execute, insert replace into save data, object name values, time last save, serialize current time. Okay. We're gonna copy that, and this is gonna be. Well, this should be done. Well, if we gave them the same timestamp, there's really no point in doing like this one having a timestamp and then this one having a different timestamp because the data in them is going to be the same, right? Well, no, not necessarily. Like, because in that rare scenario, if we crashed. Well, hold up. Let me think about this. So, if we have our timestamp that's made once at the beginning of the function, we ran stable right here, then it would have that new timestamp. It crashed. When we reconnect, it would load this one because it knows that one has the most recent timestamp because this one would have an older timestamp. In the case that backup was first, it would have the new timestamp. It would load from backup because stable would have an old timestamp. So I don't think there would be a reason to do a timestamp for this one and then another timestamp for this. Does that make sense? Does that make sense? I feel like that makes sense. Yeah. Like, we don't need to double up. I don't even think there's an edge case where we might need to double up on the timestamp. I mean, you could say, well, what if this one is corrupted? Well, if this one is corrupted, then it doesn't matter, right? We're going to go to backup anyway. And then the same thing with this one. If that one is corrupted, we're going to go to that one anyway. So, like, it doesn't really matter what the timestamp is at that point. It just matters which one is stable and which one is not. Because obviously we can't load from a corrupted one. Yeah, that's pretty smart, I think, anyway. So let's go ahead and say, yeah, this is good. We're done. Like, I don't think we need to add anything else. So we have current time, time equals time ns, serialize current time, pickle dumps current time. Create upserts the time last saved to reference last table save state timestamp for proper reconnects because sometimes we update a stable backup first. Right, insert or replace into save data, object name, value, values, placeholders, time last saved as the object name, and then the serialized current time as the associated value because it does have to be a blob. And then we do basically the same process, but for checkpoint ID, we do serialized checkpoint ID since it must be blob. Yeah, since must be blob. Right. Okay, so everything else has been thoroughly reviewed. There's really no more improvements we can make. This has been super, like, triple checked to the utmost. Should not be any connections. Yeah, so this is great, man. I did so good on this section, I feel like, honestly. So now we're just gonna do a final test real quick. And then I'm gonna go outside and take a little break, and we're gonna come back and do one more session. But yeah, this is gonna need to be deleted. I think we probably have these database files because I'm too lazy to code it into the script to check that first and delete them if they exist. There we go. So everything worked. Surprise, surprise. I got it right. Now, I don't ever want to see this file. I don't want to look at this file or this function ever again, hopefully. This was honestly kind of nightmarish. I really don't. I hate the if else, well, if else this and if else that. Like, that's what programming ultimately is, but some of these edge cases, it just makes you feel like, why am I doing this? Like, is this ever going to even occur? Like, you're adding layers of complexity and security to account for the most rare scenario, like 1 in a million, you know what I mean? But that's just the way it has to be in programming. I think that's the proper way to do it, you know, because like when you go, they pass it to quality control. Quality control is going to be able to break that code unless you have it to that standard. If you don't have it to that highest standard, QC or whatever they're gonna throw scenarios at it that you're gonna be like, oh, well, that would never actually happen. It's 1 in a billion, you know. But technically, it could. And if you coded it the way that I did, at least I'm confident that it's true. It would pass that test. So, all right, moving on. Last thing we're going to do when we come back is copy and paste the new and improved code to save logic's associated section. And yeah, we're going to move on finally from this. This is it. Like, we've basically finished creating the save state system. For the most part, it's like, yeah. All right, so I'm gonna go take a break. I'll be back. I'll be back in like 5, 6, 7, 8 minutes or something. I notice I lean. I have like a tendency to lean one way. So I'll be back. Just a few. Okay, I'm back. We're gonna do just like, I'm probably gonna do 20 more minutes. We'll just say 30, right? 30 minutes is pretty short. It goes by rather quickly. I just didn't really want to do another hour, honestly. It's getting a little late. I'm getting a little tired. So let's see here. Where are we at? Alright, so next what we have to do is we need to copy and paste the new and improved code from this file to save logic associated sections. Test one more time before transferring any code, which we did test, and it worked. So this is what is next. We need to copy and paste this stuff. So let's go ahead and get rid of this. Well, actually, we delete the task after we do it, not before. So what we'll do... Oh yeah, we don't need... we changed all that. So basically, we can just copy this class database, this initial code here. Let's see. So we'll copy this, and then all the way through to save database right here. So that should be 1, 2, and then 3 indentation. Because it usually messes up indentation. Okay, so that's a lot shorter. So technically we did test this. Well, no, we didn't test visual data save function. Well, yeah, we did. Yeah, we tested that. Yeah, that's been tested. Alright, then we have save system needs to be tested. Custom append list save function. Now that one does need to be tested. We didn't modify that. Yeah, we didn't mess with that. Placeholder code has never actually been worked on. Okay, that one. To close the associated questions since they've been determined to be throwaway. Right. Also ensure any change code from there that needs to be transferred back up here is done properly. Right. That's what we're doing right now. Question, we don't need the self-stable to backup associated cursors. Yep. Right. So that's done. So what we're going to do is we're going to just copy stable save state function. Well, why do we have that one first? And here we have stable save state, and then we have update DB. In this one we have update then stable. Need to add in timestamp last save. We already added that into the copy. Last save, yep. Let's check one day for specific code locations, therefore can't be, therefore probably have to either make a client header or just leave as a global variable. Gotcha. Need to change updates function calls to reflect that we no longer have a target path. That's not correct anymore. This one has been tested, so we can get rid of that. Alright, so it goes update DB stable save state and then stable save state function. But we're changing it to be, because we tested this, we know this works. We're going to do stable save state and then update DB stable save state. Alright, so let's copy that. And then we're going to go right here. So this is stable save state and update DB stable save state. Okay, let's make sure this is pasted in correctly. Yeah, this is good, I think. We have loop data save function, stable save state function, update DB stable save state. Yeah. Alright, cool. So this is, we can actually go ahead and comment out all this code. And Let me just make sure. What did we tested? Stable save state. Yeah, stable save state in turn calls the update db stable save state, but we didn't pass in various scenarios. So you know what we should do? We should test the various if else scenarios. Meaning if path exists, else. I mean, I don't think we really need to test it. It's pretty straightforward, right? Like we'll look at it and I mean, it's always good to test though. So I guess we can go ahead and do that. It shouldn't take us long at all, just to give us that validation. Alright, so let me just go ahead and put in devlog that we did this. So we're going to change this to be 646. Perfected the test code in SQLite test.py associated with the save logic py functions. And what were the two called? Stable save state and update. Is that called update? Update db stable save state. Tested all code and verified working 100%. So it was all working, good deal. Next we're gonna go ahead and test. Tested a few more logic branches associated with the two above mentioned functions. Well, actually, we'll just include this into this task, right? Because it's basically the same thing. Oh yeah, and we also copied tested code over back over to save logic .py, overwriting the old version. Alright, so now let's go over to SQLite test, and what we need to do is we want to test the so currently what it would be doing is we would have, so we have our database, we have the initial database, we then insert into save data, then we run update db stable save state, passing in stable. Okay, and in that case it would enter into, it would go here and it would say, oh yeah, we need to import time here. Import time. Let me see. So it would go to current time, and then we go OS path stable. At this point, stable would not exist. Shouldn't anyway. So it would go to else, and then it would run this. So we'll change this to say, which function is that in? stable save function. Let's go here, and we're gonna say if OS path exists. So this would be scenario number 1. So we'll say print 1. This would be scenario number 2, print 2. This would be scenario number 3, print 3. This would be scenario number 4. Now we can't test them all, like we can't create a corrupted version, you know? I mean, I guess technically we could. We could probably do that actually. We could just delete a character from the file and corrupt it. So we might be able to test that. So we have the 4 different scenarios here. And then 5 should print every time. Just that's a simple way to verify that. Alright. So in the base case, we should have no database files existing, and whenever we go to test it, it would go to else and then print 4. So when we run this, it should print 4 and 5, and it does. Okay, now we can go ahead and delete these database files. And then verified working. Alright. 5 verified. Well, we'll put that after we test all the other ones, right? Oh. Verified working number 4. Alright. Now we'll test if OS path exists, save data stable. So if stable exists but backup doesn't exist, it would go to 3. So let's do that. Let's create a file called save data stable.db, and it doesn't have anything in it, but it does exist. Alright, save data stable. So now when we run it, let's see what happens. Okay, now it went to 4 or 5. If OS path exists, save data stable path. Data stable.db. Well, I'm a little bit confused. Why didn't it go to 3? Save data. Oh wait, I'm sorry. I'm tripping. Well, wait, no. It should go, if save data stable path exists, it would go into this, and then it would go else. So yeah, it should have print 3. Because save data stable path is DB, so it's going to go from testing out to Canasta, and then DB, and then save data stable DB. Maybe it's because it was empty. Maybe if it's an empty file, it doesn't consider, like, you know what I mean? It basically like nullifies its existence. It's sort of like when you have an empty list, it returns false. But no, it actually still went 4 or 5. So I think there might be an issue here. It should be entering, if it should go here and then else. So maybe there is an error with the path. Huh. But it creates it. It creates it when it does vacuum into. So why does vacuum into work? If vacuum into works, into the target path. If that goes to the correct place, why does it not? Okay, let me try to rerun it with all of them. So it throws an error at line 511 where it's okay, wait, does it have to do with this code where we insert into, then we do update? Oh, right, because it's internally. Okay, I see what the problem is. It's our test code, it's the execution code. Gotcha, I see. So I see. So database character code inserted values. So update is gonna. Okay, I see. So this should just be dbok. So dbok. Okay. So this should be changed. Update db. Where is it? There we go. Should just be dbok. And if dbok. There we are. Alright. OS remove target path. Blah 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 blah. So this is going to create stable if it doesn't exist, so it's gonna remove it, then it's going to recreate it. Right, so what we should be doing is we should just be calling stable save state function without this mess. Like without this, we don't even need this at all. We're just testing the actual code here. You feel what I'm saying, her? So we just want to test this function, ultimately. Yeah, there we go. Okay, I got this figured out. Now let's run it. Okay, there we go. Now we get 4 or 5. Well, I still don't know if it works. But let's leave save data stable, right? We'll delete the first 2. And then this might be... There it goes. Now it goes 3, 5. Cool. Alright, so... This one is verified working. And this is verified working number 3. So now we want to try to get number 2, which would be if db backup is okay. So if we have save data stable and backup, now if we have save data stable and we have save data backup, and if save data is okay, it should go to 1. So this one should do 1, 5, right? Oh, but we get an error at 511. Okay, because it already exists. So we don't need to run this again. It's already in there. So this is just like... That's because we're rerunning db setup. We don't have to rerun db setup at this point. You feel what I'm saying? And actually, that would be fixed if this was changed to upsert, but it's fine. This is 535. Database save data. Cursor execute, insert, replace, and save data. No type object has no attribute execute. Oh, it has no self.cursor. Okay, right. So we do have to run db setup. Is this the fact of the upsert? There we go. So now we get 1.5. So that's verified working. Oh, this is cool. This feels nice. I mean, it's simple shit, but you know, still feels nice. All right, so now we just need to do number 2, and number 2 would be if db backup is corrupted. So let's go ahead to db backup, and what we'll do is we're gonna let's open it anyway. Yeah, doesn't matter. Okay, and we're just gonna delete some shit like this. There you go. Now save it, which it should already be saved because we have autosave turned on. And now if we rerun it, now it says database disk image is says 457. So db backup is okay. So this throws an error. Database error, database disk image is malformed. Okay, so we actually have to do try except on this. So this is good. We need to do oh, there goes the helicopter. You don't really hear helicopters over here very often. I always like to look at I like helicopters. I'm like a little kid. If I see a helicopter, I'm like, let's check it out. So we do need to add a try except for this. So we need to try except, and we're gonna go ahead and I guess I was gonna say we'll stop here. I didn't really feel like doing it. I'm kind of ready to be done. So this is gonna have to be a try because this throws. We'll say necessary since this execution throws SQLite 3.database error if it's not okay. So in this case, we basically needed to, well, we needed to, what? What do we need to do? Well, if it's not okay, we just pass, right? We just pass out of it. And we would close it and well, in this case, we just pass. It's like the wisest thing to do, because since it's not okay, we still want to close it. We want to check that to see if it is okay. We know it's not, so to go to else. Well, wouldn't we just put this in the try except then? Like, if this works, it won't throw the error. But either way, we would want to close, do none, so this would not get put in the try or the except. This would remain outside to be applicable to both situations. But we could put this inside of the try. So it'll do it like that, and then except would basically be else. It's the same thing. Like this if is the equivalent of the try. It's going to go into the except if it's not good. So then in that case we would just do backup first and then stable. Does that make sense? So let's put this up here in the except, and then this would be put in the try. There we go. And this would now be 1. And then this would be 2. And this is aka elif like we don't even need to assign this to a variable. We could just do we'll just say throws error if not okay. Means DB backup is corrupted. Okay. And this would do, well, this would be an issue because we would have to, we can't close it after. We have to close it beforehand because if we didn't close it beforehand, when we ran updates, it would exist, but when it tried to remove it, it wouldn't be able to remove it because that would conflict because the file would be locked because of DB backup close having not been run. Does that make sense? Because there would still be an open connection to DB backup, so it would throw an error here and it would throw an error here in the other case. And we can't actually like close it. We'd have to execute this code twice. So it's basically we would add 1, 2, 3 lines versus adding, I guess, 3 lines. It's the same. So which makes more sense? Do we keep it the way that we had it, where we just did try except and then we would just pass? Basically, in this case, we would just say pass, and then it would close backup none. I like that scenario. Like that makes more sense. That's a little clearer as opposed to having the try and then adding the 2. Like in terms of lines, this is 1, 2, 3 lines added. Well, hold up. Well, we would still have to do the try, right? So either way, we have to do try except. The difference would be we're checking if it's okay versus else. So that's 2 lines. But if we did it the other way, we would end up having to add 3 lines to duplicate this close none none inside the try and then inside the except. So this is actually a shorter method. Does that make sense? It's actually a better method, and it's more clear anyway. So we do DB backup cursor, try necessary syntax using SQLite database if it is not okay. DB backup is okay, blah, 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 blah. And then we say except, and this means DB backup is corrupted, and then pass. Don't need to do anything in this case, just let it continue. Yeah, I think that's true. So in that, if it is corrupted, we would still close the connection none. We check that okay, and then yeah, because we have to have this get run after, or it has to be duplicated, and then So I was gonna say we could put the except code, the else in the except, but we couldn't do that because that would precede the closing of the connection, which means we'd have to duplicate that code, and that's not good. So yeah, we're gonna leave it as it is. So now let's try this again with the new code. And then it says DB backup OK is not associated with the value of the sign 464. Try. Oh, okay. So right. So we have to say DB backup OK is equal to. I gotcha. Is equal to false. Means DB is corrupted. There we go. See, I'm an idiot. So now we got 2 and 5. There we go. Because that means 2. That means it was corrupted. Verified working. And then 5 ran during number 3. So verified working number 2 rather. So we got it verified working on 4, 3, 1, and 2. We verified that 4 works. We verified that 3 works. We verified that 2 works. And we verified that 1 works. So guys, it looks like everything works here. What about if the stable is corrupted as well? Let's just go ahead and see. Let's open this up. We're going to delete some of the shit. And now it's corrupted. Now what happens in this case? Well, it just does 1.5 because backup was not corrupted, and then it does 5, and hopefully, I mean, everything would work if we retrieve the data from it. That would so that means, yeah, it created a new stable and a new backup, and in that case, stable wasn't actually stable, but you know, backup was. So hold up. Backup was stable. So honestly, well, no, yeah, we would want to do stable first because stable was corrupted but backup wasn't. So we would want to do stable then backup. And then if backup was corrupted, it wouldn't matter either way, but we would do backup stable. So yeah, we don't even need to add that clause in. So I was just verifying that. Remember, we determined we didn't actually need to add it. We don't actually need to add it. So, this what got changed here. That's in the stable save state function. So let's go ahead and copy that back over because we did modify it. Oops, wait, let's get rid of the test lines here. There we go. Cool. All right, let's copy this. Blah, 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 and get rid of that line. And I don't think we need to change anything else here. Let's go ahead and copy, or paste rather. So let's bam, paste that in. So now we got that try and accept if OS path exists. Try, DB backup is okay, accept, DB backup is equal to false. And what if it doesn't throw the error on the connection, right? Yeah, it didn't throw the error on the connection, so that should be safe. Yeah, so we're good to go. Alright guys, that's going to be it for today. So next would be to comment all this code out since we verified it does work. So let me just go ahead and do that. Be our last thing. This was good. So I need to 1, 2, 3, 4, 5, 6. Let's say 4, 22, 25. Stopped here. All right, and then next thing is gonna be gonna add note here that reminds us this code is working and has been thoroughly tested. Very true. Very true. And then after that, next number 2, what do? Well, then we're gonna continue working on what? Well, I would say continue working on next systems, I think. I just sprayed that fucking shit with peppermint oil and it's like burning my eyes right now as we speak. My eyes are literally like on fire. Alright, so this was actually 7:16, damn. So this was a long session. We tested all code by working back. Alright, and then we're gonna go 7:17 to 7:18, and this is gonna be the staging and committing and pushing our changes to the remote repo. Create a new local backup. Let's create our title here. This is gonna be save logic revision code to the SQLite type journal, and this is gonna be final testing success. Cool. And the time we ended is going to be 7:18, and that's going to put us at 2 hours and 11 minutes. So we'll just say 2 hours. Well, let's say 2.25. Fuck it. I'll throw myself an extra 4 minutes, dude. And there we go. Now let's go ahead and cd out to the proper directory, the root directory that is. There we did it. We're going to branch to make sure we're on the right branch. We are git add to stage our new changes, git commit -m, paste in our devlog message, go ahead and create that new commit, 6 files change, 181 insertions, 167 deletion, blah blah blah. Now we're going to do git push to push this to the remote repository. Let's make sure it finished. It did. Now we can go ahead and close this. Oh, you know what I forgot to put? I forgot to put stopped. Let's see. Stopped at line number 419 in SQLite tests. In SQLite test dot There we go. Alright, now we can go over here and we're gonna do the local backup. So we'll go into Canasta, we'll copy the little one, we'll back out, we'll go to backup, we'll delete the old one, then we're gonna paste in the new one. There you go. Now we're gonna go to text, devlog, we're going all the way to the end. There you go, 422 baby, and that's going to be it for today. We're just going to rename this to reflect today's date, the last date on which we created a new backup. And that's it, dude. So I'll see you next time. That was a good session. It took a little longer than expected to do the final revisions and review and test on that code. The testing was actually easy though, and everything was a success, so that's always nice. There weren't any bugs, just a couple minor ones we fixed, and yeah, so now we're moving on. So we're done with that finally. That was like, what, a week or so of working on that, maybe even more. That might have been like 20 days from start to finish, like from the true start, like brainstorming and shit or whatever, like the first pass pseudocode to the final tested form. Not terrible, you know, like I didn't code so much during that period, so it was I'd probably say it was like 15 hours, maybe 20 hours total of coding to do that, which isn't terrible, you know. It's not great, but I definitely got better. I probably did have to spend some time learning, so now that I know it, I can do it again. Hopefully easier next time. But yeah, so next it's going to be making the logic for the re-entry points whenever we reconnect, and like finishing that up and getting that tested. And that's going to be kind of difficult, I think, honestly. I haven't really been looking forward to that, but I don't know. Sometimes things end up being a little bit more simple than you think. Like, simple on the macro, but more complicated on the micro, if that makes sense. If you've ever coded before, you might know what I mean. Like, the overall system actually ends up not being not as complicated, but like, you know, the little details are kind of complicated. Like the specific code that you use and stuff might take longer than expected. But as long as I can make it work, you know, like that it's not a failed system, um, the micro is fine. If it is what it is, you know, whatever it's got to be is what it's got to be. I'm not gonna like revise the total system because micro is complicated. But yeah, we basically got this taken care of, and we're moving on to the next system, or the next part of this system, and I'm pretty excited about that. I think that we'll have good success. I think everything is in place for us to move to that. Maybe I'm wrong. I'll have to look at my things to do and, you know, check some shit out. And honestly, this is like the last thing. This was the last thing for this entire project. So we're almost actually done. I can't believe I'm saying that. I've said that multiple times, but like this is the last system. Was this perfect save system. And well, there's a couple minor ones I forgot, like the menu screen we didn't do. Menu screen is going to be so easy to add though. Like that's nothing. That's a day or two maybe. That's nothing like this. I wouldn't even call that a system. It's just like, it's not even a feature. You could call it a feature, but it's like 10% as, you know, of what we just did. Super simple shit. So it's just like creating a little screen to click a button, a couple different buttons, which half of that work's already done. Other than that, there's like a little bug with card ghosting movement at the beginning of the game, or I think it actually persists throughout the game. That might be a little bit of a pain in the ass to figure out, but it might be simple. We might be able to figure it out rather easily. It's not a game-breaking bug. I'm not super worried about it if we can actually get it fixed. What else? So yeah, we got that minor bug. We have the menu screen thing we have to add. We have to do the checkpoint re-entry, which is the big feature to add, and and then it's just basically testing the game, going through our things to do, doing things like that we don't necessarily need to do, but that we wanted to add, like little minor code improvements here and there, just to kind of pretty it up, tidy everything up, make it nice and clean, remove all our caution comments and stuff, and then we just do some testing, right? Test it to make sure that it runs, and then we're done with this, and we can actually like deploy it. You know what I'm saying? We can actually like host it. However we're gonna do that, that's a new thing to me. I've never actually deployed a project before, because like this is my cornerstone major project. I chose a really big project, and it's finally coming to an end after, well, 4 years honestly, but since we started the online version, it's been about, what, a year and a half, 2 years maybe. At least, I would say at least a year and a half. So yeah, big project finally coming to a close. So